A truck starting from rest moves with an acceleration of 5 meter per second square for 1 second and then moves with a constant velocity. The velocity with respect to ground versus time for the block will be equal to. Now over here the relative velocity of the block with respect to the truck will be the velocity of the block with respect to the ground minus the velocity of the truck with respect to the ground. Okay. Now over here if I want to calculate the velocity of the block with respect to ground, it will be equal to velocity of the block, relative velocity of the block with respect to truck plus the velocity of the truck with respect to ground. Now let us calculate each of them. What is the velocity of the truck? Now the truck moves quite simply. Okay, it will be equal to v is equal to u plus at. The initial velocity is equal to 0. So vt of the truck will be equal to a into t, which is equal to 5 into t. Okay, which will be equal to 5 into t because its acceleration with respect to the ground is equal to 5. Now the velocity of the block with respect to the truck. For this, what we do is, now since the truck is accelerating on the left hand side with the acceleration a, there will be a pseudo force which will act in the right hand side with the acceleration a. There will be mu g will be, that is the friction force or the friction acceleration will be in the left hand side direction. Since the block is accelerating towards left, then I can say that the acceleration of the block with respect to truck will be equal to, that is mu g minus a. Okay, the friction force or the friction acceleration due to the friction force minus the pseudo acceleration or the pseudo force. So this will be equal to mu g. Okay, mu g will be equal to, over here mu is 0.2. okay, mu is 0.2 minus the acceleration of the truck, which is equal to 5. Okay, now this is the relative, this is how the relatively the block will proceed on the left hand side direction. Okay, now over here if with respect to 0.2 into 10, okay, which will be equal to 2. Okay, so if you see with respect to the truck, the block is accelerating in the right hand side direction. Okay, with the acceleration minus 3 or in the right hand side direction. So the final velocity of the block with respect to truck, we will be using again v is equal to u plus at. Again the block is at rest with respect to the truck initially. Okay, initially. So now it will be equal to minus 3 into time t. Okay, so if I calculate this value, the relative velocity or the velocity of the block with respect to ground will be equal to v bt plus vt. Okay, so which is equal to minus 3 plus, it will be equal to at. Okay, so the acceleration will be equal to over here, acceleration will be equal to the acceleration is given as 5. Okay, so it will be equal to 5 into t. So basically it will be equal to minus 2t, or sorry, plus 2t with respect to the ground. Okay, with respect to the ground it will be equal to 2t. Okay, so now if the block is accelerating for let us say for 1 second, it will go from, this is the first section, which will be equal to 2 into t. Okay, for the first part it will accelerate on the right hand side, which will be equal to 2 into t or 2 into 1. So from 0 to 1 I will obtain a graph somewhat like this. I will see the final graph later. From 0 to 1, time versus the velocity, I will obtain a graph somewhat like this, that is 1, 2. Okay, now let us proceed. We have to calculate after 1 second what will happen. Okay, after 1 second there will be no acceleration of the block. Okay, there will be no acceleration of the truck. Okay, the block will retain its original velocity of 2 meter per second. Okay, the block will retain its original velocity of 2 meter per second in the left hand side direction. But now as the acceleration stops acting, what will happen is, once the truck stops accelerating, the block as well as the truck should obtain a certain constant velocity. Okay, should obtain a certain constant velocity, that is the constant velocity of 5 meter per second. Okay, it has to obtain a constant velocity of 5 meter per second after certain time. Okay, so now the velocity of the block is 2 Now the block has only one acceleration, that is the frictional force, as I have marked over here. The block will have only one acceleration. Since the truck has stopped accelerating, this will be equal to 0. So now the acceleration of the block is equal to 2. Okay, now the acceleration of the block is equal to 2. Now it has to gain a final velocity of 5. Initial velocity is equal to 2. Okay, now the acceleration will be equal to 2. So the time taken to reach this velocity will be equal to v is equal to u plus at again. Okay, v is equal to u plus at. So v is equal to 5. Okay, initial velocity is equal to 2, a acceleration is 2 into time. So if you calculate the time, 3 by 2 will be equal to 1.5 seconds. So total it takes, so initially from 0 to 1 second, it has acquired a velocity of, from 0 to 1 second it is accelerating in the right hand side direction with respect to the block. Okay, with respect to the truck, sorry, with respect to the truck it is accelerating on the right hand side, but with respect to the ground its acceleration is equal to its acceleration is equal to 2 meter per second. Okay, its acceleration is equal to 2 meter per second with respect to the ground. Okay, so with respect to the ground, okay, we will get it somewhere over here. Okay, with respect to the ground its acceleration is equal to 2 meter per second over here. Okay, but now after 1 second, it takes more 1.5 seconds to reach a velocity of 5 meter per second. So after more 1.5 seconds, that is 2.5 seconds, after 2.5 seconds it reaches a velocity of 5 meter per second. So if I plot the graph, I will get the graph somewhat like this. Okay, and after that, since both of them, the truck as well as the block, will acquire the same velocity, it will move with a constant velocity after 2.5 seconds. So the correct option is option number C.